This time on Battle Factory, a suit that's tailor-made for the world's most dangerous job. Looking down the barrel of a semi-automatic weapon, a combat-ready boat you can launch from the sky, and a portable missile launcher that's right on target. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When these pieces of hard plastic and bulletproof fabric are molded and stitched together, they'll make a suit of armor that's tailor-made for the most dangerous job in the world. For the bomb disposal specialist, going to work means putting his life on the line. During the Blitz of World War II, the first modern EOD, or Explosive Ordnance Disposal, was established to deal with unexploded German bombs that landed and lodged in London streets. The first operatives worked unprotected, and detonation meant certain death. It wasn't until the 1980s, when British bomb squads were handling IRA explosives, that the protective suit was developed. In combat zones like Afghanistan, where soldiers are more likely to be killed by an IED than by gunfire, bomb disposal specialists are in high demand and at high risk. When a patrol spots something suspicious, the bomb squad is dispatched to investigate, and one operator will suit up and head out alone on what has been referred to as the long walk. The bomb suit is made up of the helmet, the outer shell, the soft armor, and the hard armor. The hard armor is made from a stack of multiple sheets of polyethylene that are placed in a press. Heat, steam, and 1,000 tons of pressure fuse the sheets into a shield that's 10 times stronger than steel and made from the same tightly woven fibers that protect armored cars. Then, the shield is cut into 3 curved plates for each of the body's vital areas: the chest, groin, and the throat. The shield deflects the bomb's high-impact shock waves. Shrapnel has a tough time penetrating the armor. During a tour of duty in Afghanistan, Staff Sergeant Carl Badger Lee's steady hands and cool head have racked up the record for dismantling twice as many IEDs as anybody else. He's defused 139 bombs, 42 of them in one village alone. In 2010, Badger was awarded a medal for his acts of bravery by Prince Charles. He also saved thousands of lives. While the hard armor protects against a worst-case scenario, when you're picking up bombs, you still have to be able to move. So the bulk of the bomb suit is made from flexible, soft armor that bends and stretches with the wearer. Sheets of bulletproof synthetic material called aramid are rolled onto the cutting table. Patterned stencils are laid over the material, traced and cut. When a bullet or shrapnel connects, the fabric softens the blow by catching it in the tight-knit weave, like a spider web, and spreading the impact across the material. The bomb suit helmet starts as rectangular pieces of ballistic material, which are forced into a rounded steel mold. A heat-resistant balloon is dropped into the mold and connected to an air supply. The balloon is inflated, and the mold is placed in a kiln. The pressure and heat of the kiln shape the helmet. Once the shell is baked, the balloon is deflated and removed. The helmet is cut into shape with a handsaw. The surface is sprayed and baked to a hard glaze. The hard and soft armor are stuffed into the outer shell, and the helmet is fitted with accessories like lights, a communication system, and a protective visor. After 40 hours of careful craftsmanship, this bomb suit is complete and ready to be tested. Even though a sample from each batch is put through rigorous testing, wearing a bomb suit does not guarantee you won't get hurt. But if you dismantle bombs for a living, you want your work clothes to give you a fighting chance and make the most dangerous job in the world a little less dangerous. Coming up on Battle Factory, the business end of a C7 rifle and an inflatable boat that can take a bullet without sinking. What starts off as a 7-pound bar of steel will soon deliver a bullet with deadly accuracy. The barrel of a Colt C7 assault rifle. In the Gulf War, Rwanda, and Afghanistan, the Colt C7 has served as the standard-issued weapon to soldiers around the world. And a rifle's ability to shoot straight and aim true is built right into the barrel. Cylinders of high-carbon tooled steel move along a conveyor belt to a machine which can precision drill the 10-millimeter holes in up to 4 barrels at a time. It takes about 10 minutes for the carbide bit to drill through the bar. Every barrel is checked by hand to make sure the bore is clean. The C7 fires 15 rounds per second at speeds of over 3,500 kilometers an hour and has an effective range of up to 620 meters. Even the tiniest scrap of dirt could throw a bullet off its target and make the rifle dangerous to fire. Bosnia, 1993, was the first time that the C7 saw action, and it was an historic battle. Canadian peacekeepers were forced to draw their C7s to defend their position, a civilian village against a hostile military invasion. They were outnumbered, but not outgunned. In what was considered one of the most severe battles since the Korean War, the Canadian forces, armed with C7s, managed to defeat their adversaries. A robotic arm sends each barrel into the hammer forge. 4 synchronized hammers pound on the bar, which shrinks the bore diameter, stretches the barrel, and toughens the steel. Meanwhile, the barrel is squeezed around a spiral-shaped tool that forms the rifling, a unique corkscrew design on the inside of the barrel. These grooves in the barrel cause the bullet to spin and fly straight. They also etch a ballistic fingerprint in every bullet that'll match the gun it was fired from. Coming out of the hammer forge, the barrel has grown 20 centimeters. A technician inspects the barrel's interior, checking the grooves that make up this rifle's fingerprint. The barrel is dropped into a 1.8-meter deep firing pit, and a single high-pressure test bullet is fired. This determines if the explosive impact will cause any damage to the barrel. The barrel is soaked with oil containing fluorescent iron particles. Then it's run through a magnetic particle inspector to check for flaws. An electric current makes any crack in the barrel magnetic. The iron particles accumulate around even the tiniest flaw, which is visible under black light. Less than 1 in 100,000 barrels are found to be defective, but this test is critical. After a month's worth of work, the test discovers a crack barely a fraction of an inch long. The barrel is rejected. A fracture might lead to the rifle literally blowing up in the shooter's face. In Bosnia in 1993, Canadian forces were in their first major gunfight in almost 40 years. But with the help of the C7 assault rifle, they redefined what peacekeepers can do, and thousands of lives were saved. After meeting the demanding standards of the C-Series assault rifle, the rest of the barrel is assembled. Once the barrel is complete, it's hammered onto the stock. The C7 assault rifle is an extension of every soldier on the ground. The barrel is a critical extension of the C7. The action loads and fires the ammunition, but where that bullet is headed depends on the barrel. Coming up on Battle Factory, a boat that can take 20-foot waves, enemy fire, and still stay afloat. And lightweight artillery that packs a heavy punch. This sharp-edged wedge of steel is built to cut through and rise above just about anything the ocean can throw at it. From police operations to amphibious assaults, the Zodiac Hurricane is the go-to vessel for deploying Marines, Navy SEALs, and special forces around the world. Whether it's launched by land, aircraft, or off the deck of a ship, this boat is virtually unsinkable. The Zodiac Hurricane breaks down into 3 parts: an air-filled rubber collar, the crew compartment, and an aluminum hull. The first step in construction is building the hull. 1-meter pieces of lightweight aluminum are welded together to form the 9-meter structure. The bulkheads are then lowered onto the hull and hammered into place to provide structure for the frame. Then they're welded together. The welds are ground down to a smooth finish. The hull's deep V shape minimizes resistance, which increases speed and stability. The Hurricane's got a step system across the bottom and the rear sections of the hull. This air-channeled system reduces surface contact with the water, which makes for faster acceleration and better handling. That speed and agility made the Zodiac Hurricane a key player in 2009's Operation Atalanta. In the Indian Ocean off the coast of Somalia, an EU Navy ship lured pirates out to sea by posing as a merchant vessel that was vulnerable to attack. When the pirates got close, the Navy turned about and launched a coordinated attack of high-speed Zodiac Hurricanes and helicopters to take down the pirate ship and bring the raiders to justice. When you take a wave at 50 knots, the Zodiac Hurricane hits the surface with bone-crunching impact. But on board, the passengers are cushioned from the blow. Once the seats are assembled, testing can begin. The seats are tested for strength and durability. They're mounted on a miniature V-shaped hull. Sand stands in for water. The rig simulates a 136-kilogram passenger hitting the water with 3 Gs of force, enough impact to knock a person out or even kill them. If they can take the hit, the seats are installed. The final step in the assembly is the inflatable neoprene collar. It's what makes a Zodiac a true Zodiac. The collar stabilizes the boat in rough water and acts as a shock absorber to reduce the bounce in the ride. The collar is manufactured from neoprene rubber, which is rolled out, measured, and cut. The pieces are carefully glued together using a heavy-duty cement to make sure the tube is watertight. And once the cement is dry, the collar is inflated and double-checked for air leaks. In a skirmish, the collar's outer layer of hard foam is designed to absorb a spray of bullets. But if one gets through, the collar has 5 separate air chambers, so it can take a hit and still stay afloat. Before installation, the collar is deflated. The collar is then slid on and fastened to the hull.
1, 2, 3.
Whether it's a high-speed pursuit, onboard assault, or anti-piracy operation, the Zodiac Hurricane is equipped for combat. Coming up on Battle Factory, it takes seconds to put together and can drop a shell 6 clicks past enemy lines. Once these steel tubes are honed, they'll become portable missile launchers. An infantry weapon that's highly effective and deadly simple. The M252 81mm mortar can trace its roots back to the Stokes mortar, first used in World War I. This lightweight muzzle-loading artillery fired explosives that could arc over enemy barricades and land in the trenches. First introduced by the British in 1915, it soon became the most widely used mortar among the Allied armies. The modern-day M252 mortar assembles in seconds, can be transported over any terrain, and drops 15 rounds per minute with a range of almost 6 kilometers. The M252 mortar breaks down into 3 components: the cannon, the mount, and the base plate. The base plate starts out in a cutting-edge machining center and is milled to be both sturdy and lightweight. It's showered in coolant to reduce friction and heat. And when it's finished, it will only weigh 13 kilos. The base plate stabilizes the mortar so it can fire accurately no matter where it's set up. It also absorbs the recoil that would otherwise drive the cannon into the ground. The base plate and the rest of the rig have to be lightweight enough so that once rounds have been fired, the mortar can be moved out fast. The core of the mortar is the steel cannon that launches the shells. When a shell is dropped into the mortar, a primer connects with the firing pin and ignites the propellant, which creates the explosion that launches the shell from the cannon. The bottom of the cannon is etched with cooling fins. With a round firing every 4 seconds, the mortar cannon gets red hot. Cooling fins are grooves that expand the surface area and draw the heat away from the barrel wall, making it possible to keep firing the mortar. But mortars aren't used solely for warfare. Sometimes they're used to trigger mini avalanches. These precisely controlled explosions loosen the snowpack before they can build up into major avalanches that would block the nearby highways and put people in danger. The mount on the mortar serves triple duty. It stabilizes the cannon, helps absorb the force of the blast, and can adjust the angle for aim. The mount's shock absorber uses springs to dampen the mortar fire's recoil. Once the mount is assembled, a hand crank can adjust the angle. During a mortar operation, every second is critical. On the front lines, mortar teams use this lightweight, compact weapon system to support infantry and penetrate enemy blockades. And like the mortar itself, the team is a synchronized unit acting as one to achieve maximum impact and maximum effect. This time, on Battle Factory, a personal flying machine that takes surveillance to new heights. A GI jacket that blends into the background. An army base you can pack on a truck and drop on the front line. And an all-terrain vehicle that never touches the ground. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When this piece of lightweight aluminum is cut and tooled, it will become the frame of a personal flying machine. Strap on the Parajet, take off from just about anywhere, and soar to an altitude of 3 kilometers. Used by military operatives, drug enforcement agents, and first responders, it gets you in and out fast, whether you're carrying a camera or a gun. Since implementing the Parajet, flying cops of Florida's Palm Bay Police Department are now able to spot stolen vehicles and locate marijuana grow fields from the sky. The Parajet breaks down into the engine, the wing, and the airframe. The first step in making the airframe is to machine the base plate. It's made from super strong aircraft-grade aluminum. This is the heart of the airframe that will hold the engine and gas tank on one side and the harness on the other. As the computer-controlled cutting machine carves out the base plate's holes and contours, it is soaked with a coolant that lubricates the tool and keeps it from overheating. Holes are machined out of the aluminum to make the airframe even more lightweight. The same process is applied to all other parts of the airframe, including the pivot arms. The pivot arms are what connect the base plate and the flyer to the wing. They control direction either by hand or by shifting weight in the harness, leaving the pilot's hands free to hold a weapon, a medical kit, or a camera. The Parajet is designed to snap together quickly in the field without tools, so every part is machined and measured down to the fraction of a millimeter. This fit has to be perfect to withstand wind and engine vibration. It can't come apart at 3 kilometers in the air. Once the metal pieces have been cleaned and measured, they're shipped off-site to be treated for strength and weatherproofing. The freshly treated parts are returned to the shop floor, and assembly of the airframe can begin. First, 6 spars are clipped to the base plate to form the framework. Curved aluminum completes the cage, which protects the pilot from the propeller blades. A fuel tank is hung on the base plate, which will last for 3 hours of flying. Netting forms a barrier between the flyer's arms and the blades. Finally, the 27 horsepower engine is mounted to the base plate. If the wind is right, the Parajet can carry a flyer at top speeds of 65 kilometers an hour. Next, it's time to connect the harness. The harness attaches the Parajet to the pilot. It gets snapped onto the base plate and bolted to the pivot arms. The propeller is made of 2 lightweight carbon fiber blades. They're fitted together and bolted to the engine. Before the Parajet can take to the air, it has to go through a hang test. This is to ensure it can hold the weight of a pilot. The Parajet is strapped on and clipped to a parallel bar. The suspended tester shifts and stresses the harness to make sure everything is holding tight and secure. The engine is revved to the red line, around 7,500 RPMs, to make sure the engine is putting out enough power without shaking loose the frame. Having passed the factory trials with flying colors, the Parajet is ready for a sky test. The device breaks down into mission-ready components. In the field, it's reassembled in 5 to 10 minutes. The flyer pulls the starter to get the motor running. Using Kevlar core lines, the flyer connects his harness to the Parajet's wing. It's made of the same ripstop polyester fabric that parachutes are made of. The flyer runs against the wind and takes a flying leap. The test pilot puts the Parajet through demanding maneuvers, banking and diving, and turning the craft by pulling the hand toggles to steer. It is capable of precision flying, multi-range destinations, and can carry up to 280 kilos of pilot and payload. So whether the mission is bringing back intel, getting a bead on contraband, or locating a victim in harsh terrain, the Parajet turns the well-trained pilot into a spy in the sky. And once you see the Parajet suspended in the clouds, you will believe a man can fly. Coming up on Battle Factory, a camouflage jacket that disappears in the dark, and a portable army base that's combat ready in under an hour. This camouflage print was digitally designed under the supervision of the Canadian military's Department of Defense. Then the material is brought here and tailored into a soldier's most versatile action wear, the camo jacket. Cadpat, which stands for Canadian Disruptive Pattern, is the latest in camouflage combat wear. It's made to look good while not being seen. Uniforms were originally made with bold colors, so soldiers were easy to identify in a cloud of artillery smoke. It also made them easy targets. By World War II, GIs were wearing camo, like the American frog skin and the British brushstroke pattern. The Cadpat jacket also camouflages the wearer at night by masking his infrared signature. A classified formula in the dye makes the jacket almost undetectable to night vision scopes. It takes 54 individual pieces of rugged textile to form the jacket, and it will be worn from basic training to the combat zone. The jackets are constructed from 152-centimeter rolls of Cadpat material. A computer-generated pattern for the jacket is printed on a roll of paper that matches the width of the fabric. The paper is rolled out over 200 layers of material, a template of all the pieces required to make the jacket. A razor-sharp blade cuts through all 200 layers at the same time. The pattern's been laid out to maximize the material, so there's very little waste. The 54 individual pieces are ready to be assembled. At the sewing station, it takes 42 people almost 2 solid hours to put the jacket together. The jacket is sewn tough and built to last, with reinforced seams and strong plastic thread. There are Cadpat jackets still in active duty 2 decades after they were issued. Once complete, every jacket gets a careful inspection, testing the Velcro fastenings and pocket strength. Recruits only get 4 changes of uniform for their entire tour of duty, so durability is critical. 1 button out of place, and it doesn't make the cut. As a security measure, every Cadpat jacket gets its own serial number. That way, each and every uniform is accounted for. If it wasn't assigned to you, wearing this jacket is against the law. The Cadpat jacket is tested by soldiers for soldiers. On the training field, they'll make recommendations to improve comfort and utility that are incorporated into the new design. Vents along the back and elastic around the torso allow for easy movement. The high-color, indestructible buttons and non-reflective zippers seal the jacket around the wearer and insulate the soldier against the elements. Once it's issued to a recruit, the Cadpat jacket will do double duty as training gear and combat uniform. Whether they're shipped out to Kosovo or Kandahar, the uniform will last for as long as the soldier's term of service. And that jacket won't just keep the soldier warm and dry, it'll help keep him alive. Coming up on Battle Factory, no matter where the fight takes you, you've got an Army base in a box. And no matter what the terrain, this craft will get you there. These boxes may look like standard storage containers, but these stackable, shippable units can travel to combat zones anywhere on Earth. And in 30 minutes, they can unfold into a fully equipped military facility. They can be customized into command posts or science labs, hospitals or barracks. These mobile military shelters can create a working Army base in the middle of nowhere in a matter of hours. Each unit breaks down into 2 parts, a rugged metal container and high-tech tenting that can expand into 27 different workspaces and living areas. The mobile military shelter starts out looking like a standard steel shipping container, but it's about to be equipped with everything you need to make it practical and comfortable, starting with insulation. Every surface is coated with a heavy-duty foam insulation. It's mixed with a chemical called cyanide, so it hardens quickly. Cyanide is highly toxic, so the area is restricted to workers wearing safety masks. Once the insulation is complete, each of the 2,600 parts, including locks, frames, and handles, are painted military green. This reduces the unit's infrared signature, making it tougher to detect. The doors are insulated with rubber weather stripping to protect against extreme conditions. Whether it's 50 above or 50 below, the weather outside stays outside. Next, the container is fitted with wiring to power up everything from radars to microwave ovens. The unit's generator can run enough air conditioning to cool a 3-bedroom house. A fresh air intake keeps the atmosphere inside comfortable. One tank of diesel can put out enough power to charge 2,600 smartphones. Once the unit is assembled and wired, it's ready for testing. It has to be able to weather any storm, so it's put through a high-pressure hose down on all the joints and seals. If it can't handle the outside, they don't start work with the inside. When the Canadian Department of Defense needed to keep warm in the Arctic, a Hercules transport plane airdropped instant shelter onto the sea ice, 80 kilometers north of the most northern landmass on Earth. Once it's passed the water test, the unit is ready for tenting. The exterior metal walls drop down to form the expanded floor, and the built-in tenting material forms the walls. A wafer of high-tech bubble wrap is sandwiched between 2 layers of PVC. This insulates the tenting against Arctic chill and desert heat. The tenting is unrolled and support rods are installed. The expanded unit builds out to 37 square meters of modular floor space. It can be outfitted to any one of 27 different units, including satellite imaging center with radar system tracking device, vehicle repair depot equipped with hydraulic lifts, or a field hospital complete with exam tables and medical equipment. To make the unit transport ready, furniture and gear are locked snugly into the middle of the container. The finished container is secured to the back of a military vehicle and test-driven, hitting the road hard to simulate rough transit. After the shakedown, the unit is parked. The walls come down and the tenting goes up. Every piece of gear is put in place and tested to make sure that when this mobile military shelter is deployed, it will do what it's supposed to do, where it really counts, in the combat zone. Coming up on Battle Factory, when you need to get over land and sea and snow and swamps, this ride feels like you're floating on air, because you are. When these PVC panels are filled with air, they can transform a boat into a hovercraft. The hovercraft is a hybrid vehicle. Propelled by air, they can float on water, land, ice, or sand, which makes it the perfect vehicle for troop carriers, amphibious assault, and search and rescue. So when an F-16 went down in Utah's Great Salt Lake mudflats, hovercrafts raced to the scene over land and water and were able to reach the pilot in time to carry him to safety and recover sensitive cargo at the crash site. The hovercraft is made of a cab, skirt, propeller system, and an inflatable hull. The high-strength PVC hull has 5 separate buoyancy chambers. Even if 3 of them lose pressure, the hull will still stay afloat. Once the hull is inflated, The frame is lowered onto it. The hull is treated with marine-grade silicone to make sure it slides on smoothly. Then the frame is bolted into place. The skirt is what makes the hovercraft hover. When air is fanned under the hull, it's trapped in the skirt. When the pressurized air exceeds the weight of the craft, it starts floating on that cushion of air, which means the hovercraft can go just about anywhere. To make the skirt, heavy gauge PVC is rolled out onto a table. Using a grease pencil, the pattern is traced and cut. Every piece is made to measure. Heat-activated glue is brushed onto the strips, which are stretched over a skirt-shaped wooden template. Once all the panels have been joined together, the horseshoe-shaped skirt is ready to attach to the hull. The underside has been brushed with adhesive, and the completed skirt is pressed onto the hull. Then it's hoisted and flipped, and the skirt is wrapped around the hull and heat-sealed tight. Then, 16 hollow rubber panels, or fingers, are zip-tied to the bow. When the skirt is filled with air, the fingers create an impact-absorbing curtain around the nose of the craft, which makes for a smoother ride in rough water. If the fingers get damaged, they can easily be replaced or reattached in minutes. The hovercraft is equipped with a variable pitch propeller system. Gimbals on every blade enables the propeller to pivot and rotate on its axis, and gives the hovercraft the ability to brake and glide in reverse. Rotating the propeller on a spindle, the tech checks that all the blades are weighted exactly equally, adding a washer if a blade is even the tiniest bit out. A misaligned propeller will cause major vibrations when spinning at top speed. Once complete, the propeller is mounted in the cage to protect it from getting clogged with bits of debris. 3 rudders are fastened behind the propellers, which directs the airflow and steers the hovercraft, not unlike a helicopter. Finally, the fiberglass cab and seats are dropped into the frame and bolted in. The dashboard containing speedometer and pressure gauges, throttle, and steering systems are installed. The hovercraft is good to go, ready to glide over land and water. With its wide skirt and low center of gravity, the hovercraft is almost unsinkable, even at top speeds of 100 kilometers an hour. Part boat, part airship, all terrain, the hovercraft is mission ready, no matter where that mission takes it. This time on Battle Factory, a sharp-looking weapon that's been a cut above since World War II. When you need to get 250 tons in the air, it's the only way to fly. Aiming for an enemy that's 2 kilometers away. And a mini-bomb that fights fire with fire. Battle Factory steps beyond the front lines into top-secret factories where combat gear is built for battle. When pounded with 100 tons of force, This sheet of steel will produce a blade that's honed by old-world craft and cutting-edge technology, and make an iconic knife that's as versatile as it is lethal. The K-Bar fighting and utility knife first saw action in 1942, when it was issued to the U.S. Marine Corps during World War II. Originally intended for hand-to-hand combat and basic needs, soldiers soon found that they were using the knife to defuse landmines, dig foxholes, as bayonets on rifles, and to open ammunition containers. For 70 years, it's been the favorite combat and utility weapon for service men and women. The knife is made up of a leather-crafted handle and a razor-sharp blade of tempered steel. The first step in making the knife is to take a sheet of steel called chrome vanadium and coat it with oil so it won't rust. Then, the 100-ton press punches out the blade. This kind of metal, used exclusively by K-Bar, is flexible and easy to sharpen. The added chrome makes it tough. The next step is stamping. Both the logo and the signature groove are stamped into the knife. This channel is called a blood groove, designed to make it easier to pull the knife from its target. Once they've been stamped, the blades move through a flat grinder. The blade is tapered towards the tip, creating a double edge, which gives the knife its signature look. The handle of the K-Bar knife is made up of leather washers. The washers are stacked tight onto the blade handle with a compressor. Then, all the leather pieces are hammered into place and capped. The cap is then secured with a steel pin, so the new leather handle is kept tightly in place. Next, a sander cuts deep grooves into the leather and smooths and tapers the handle for a better grip. Now, the handle is ready for painting. A brick of wax is loaded into the machine, and the leather rotates around it. The wax protects the handle against wear and moisture. Then, the grooves are colored with a black dye, which soaks easily into the leather. And the handle is complete. Each side of the cutting edge is sharpened by hand to exactly a 20-degree angle. Any thicker, and the knife will be dull. Any thinner, and the blade won't last. A skill that takes a master craftsman years to perfect. Finally, the blade is polished against a cotton wheel. This buffs the metal and removes any imperfections left on the blade. Once polished, the master craftsman takes each blade and slices it through a piece of paper. If the knife is too dull, the paper will crumple, but if it slices cleanly, it's ready for testing. First, a laser beam measures the angles of the cutting edge. If it's 1 degree off the 20-degree sweet spot, it goes back for resharpening. If the angle is accurate, the blade must pass the rope test. If it can't get through a piece of nylon rope in 2 slices, it doesn't make the cut. Then the knife is checked for imperfections. Even the smallest flaw means it's sent back for refinishing, or ends up opening boxes on the factory floor. Once the knife has passed inspection, it's boxed up and shipped out for active duty. The K-Bar knife has served alongside generations of fighting men and women. Whether it was close-quarter combat or opening a can of rations, the K-Bar was built to give a soldier the edge. Coming up on Battle Factory.
This high-tech transport weighs 65 tons, and it's lighter than air. And a sniper's bullet that travels 3 long seconds to connect to its target. When these aluminum struts are joined together, they'll make up the shell of an airship that's never been seen in the sky before. Aeroscraft is the first of its kind, a 21st century take on the Zeppelin airship that has been part of flying tradition since the 1900s. Zeppelins of the day were originally designed as passenger ships and couldn't lift much cargo, and they were powered by highly flammable hydrogen gas. The Aeroscraft might look similar, but this military-funded prototype could revolutionize cargo and personnel transport. Airships of the future will be able to carry up to 250 tons of cargo and be able to take off and land vertically on any terrain with no need for a runway or ground personnel, making them the perfect transport system for bringing aid to ground zero in the aftermath of an earthquake or a hurricane. It took 10 years and $35 million to get the Dragon Dream prototype this far. But before it can go into full production, this experiment has to prove it can get off the ground. The Aeroscraft is made up of the helium buoyancy system, the aeroshell, the control center, and a rigid structure. The rigid structure is the skeleton of the Aeroscraft. It's made of lightweight aluminum and carbon fiber, strong enough to carry heavy loads and light enough for flight. Creating the trusses is like erecting a bridge. There are over 200 of them, ranging in length from 6 to 18 meters, and each truss has to be welded to the next by hand. It's taken 50 people 3 years to finally put together the form that creates the floor, the ceiling, and the cargo compartment. It's designed to be strong enough to support the propulsion system, the cockpit, and the helium containers. Helium gas is what makes the Aeroscraft lighter than air. In the past, the original airships would rise with the help of a lifting gas, hydrogen, and by dropping ballast, water. However, hydrogen is highly flammable, and an accidental spark could end in disaster, as it did with the infamous Hindenburg in 1937. Helium, which is not flammable, powers the Aeroscraft's groundbreaking variable buoyancy system. This enables it to move up and down like a submarine without taking on ballast. Simply adding compressed air from the surrounding atmosphere puts the helium under pressure, which reduces lift so the craft drops. Release the air, the helium expands, and the craft rises. So the first step in creating the buoyancy system is to make the large helium container. Made with lightweight plastic, filled with helium, and stored in the upper trusses of the ship's fuselage. It takes over 10,000 aluminum struts to make the outer shell. Wafers of honeycombed aluminum are sandwiched between each of the struts, and holes are punched out to make the aerodynamic frame even lighter. Once the shell is built, the next step is to cover it with a fabric skin made of mylar and carbon fiber. The skin is designed to deflect the heat of the sun away from the helium. Too much heat expands the gas and makes the ship harder to control. Once the exterior is complete, the glass cockpit, which includes seats and a touchscreen control panel, is suspended from the bottom of the ship. The Airship is steered by a rudder and powered by 3 engines which rotate on their bases for maximum maneuverability. The engines, wings, and the rudder are installed. After 5 years and $35 million, all the pieces of the Dragon Dream prototype are installed and ready for testing. Computer simulations can only predict so much. It all comes down to this moment. If this scale model gets off the ground, it will give the company the real-world results it needs to take production to the next level. A fleet of lighter-than-air aircraft that will be able to land anywhere on Earth and unload enough military force to protect a city, or enough humanitarian aid to feed one.
5, 4, 3, 2, 1, 0. All engines running.
Liftoff. While the Aircraft's maiden voyage only goes about 15 meters off the ground, the prototype's test flight was a success. Expectations are high. Now, the real work can begin. Coming up on Battle Factory, how to take down a target 2 kilometers away, and a plastic egg that's harmless until it hatches fire. In 48 hours, this harmless block of metal will be formed into the most accurate weapon on Earth. The AX-338 sniper rifle. Its predecessor, the AW-338, holds the record for the longest confirmed combat kill in recorded history. In Afghanistan in 2009, it was used to hit a target from 2.4 kilometers away. The AX-338 breaks down into 4 main parts: the magazine, the barrel, and the chassis and action. The chassis and action are the guts of the gun. Together they hold, feed, and fire the ammunition. The chassis is cut from a solid block of aluminum on a CNC machine, a computer-controlled cutting machine that ensures accuracy to the 10th of a millimeter. A coolant spray reduces friction and overheating. What makes this gun so accurate is that the chassis and the action are locked solid. There's never any movement between them, not even when the gun is being transported, and especially when the gun is fired. In long-range operations, even a microscopic shift means missing the target by several meters. Using the same process, the action is cut from a block of steel. The action and chassis are set aside in order to make the hinge. The hinge connects the butt of the gun to the chassis. It's made of 2 pieces of solid aluminum that join together perfectly. Once the hinge is locked in place, it doesn't budge. But when unlocked, it shortens the length of the rifle by 25 centimeters. In combat, the enemy is always on the lookout for the sniper whose longer rifle can give him away. But the ability to shorten the gun means the sniper now blends in with the other soldiers and avoids becoming a target himself. The mounting tube is an innovation developed to fasten night vision, lasers, and other accessories to the barrel. It starts as an aluminum cylinder. It is milled into an 8-sided shape with over 100 key slots drilled into its sides. The attachments hang off the slots. The mounting tube is free-floating, designed to fit over the barrel without touching it. That way, the weight of the attachments won't put the barrel off balance and affect the aim. The precision-designed barrel is 68.58 centimeters long and rifled with unique grooves on the inside wall that cause the bullet to spin and fly straight. When the bullet leaves this barrel, it'll be traveling at more than twice the speed of sound. In the record hit of 2009, the sniper's bullet took 3 seconds to travel 2.4 kilometers, or 20 city blocks, to connect to its target. For its final exam, the rifle is calibrated for 100 meters. Five shots are fired into the target. Every shot must land within this 3.5 centimeter diameter for the rifle to be deemed battle-ready. In a war zone, police standoff, or hostage-taking, the sniper is often the only solution to a bad situation. And if a target is caught in the crosshairs of an AX-338, from 20 city blocks away, he'll never know what hit him. Coming up on Battle Factory, little plastic eggs that can burn a forest to the ground. These colorful plastic eggs may look harmless, but they're actually little time bombs that can set a forest floor ablaze in under a minute. Dragon eggs are mini missiles that are launched from a gas-powered cannon. 20 seconds later, the egg ignites to spark a strategic blaze from a safe distance. Firefighters use the combustible eggs to stop wildfires in their tracks by cutting off their fuel supply, fighting fire with fire. The Green Dragon launcher is made up of 3 parts: the chemical injection system, the launcher, and the eggs. The incendiary eggs are made up of 2 halves of a plastic sphere that's 3 centimeters in diameter. The egg is fueled with crystals of potassium permanganate, a chemical that on its own is harmless, stable, and non-combustible. Until you inject them with antifreeze or glycol, which, in 20 seconds, results in a volatile exothermic reaction that flares at over 2,200 degrees Celsius, causing enough firepower to set even wet wooded areas aflame. About 10,000 of these harmless-looking eggs are produced in a single shift. Enough firepower to burn 60,000 hectares. Agencies across North America and Australia will order over 2 million eggs in a year to control wildfires. The launcher contains 200 parts and takes almost 8 hours to assemble. With only 20 seconds between injection and ignition, the launcher's got to work perfectly or the whole system can backfire. The launch mechanism incorporates a 4-cycle system that moves the egg into the chamber, injects it with glycol, drops it into the barrel, then launches it on a blast of air. In Bosnia in 2012, Dragon eggs were fired from the turret of a tank to clear overgrown minefields almost 20 years after the conflict. On the firing range, the glycol reservoir is filled up, and up to 450 Dragon eggs are dropped into the hopper. The Green Dragon is armed and ready to deploy. Dragon eggs can be launched from a moving vehicle or dropped from the sky. The eggs are launched 40 times a minute and need to travel up to 60 meters in order to keep people out of the hot zone. The chemical reaction starts in the air, but doesn't fully ignite until the 20-second mark, once the innocent-looking egg hits the ground a safe distance from the cannon and the operators. This little plastic sphere may look like a child's toy, but when armed, it has the power to starve a wildfire or clear an overgrown battlefield.